The next kind of problem we're going to tackle together falls into the category of what we call a work problem. In these kinds of problems, it will generally be the case that we have two or more people working together to carry out a particular task. Now, the problem we're going to look at is the following. It tells us that together, John and Lee can paint a house in 2 hours. It would take Lee 5 hours to paint the house by himself, and the question is, how long would it take John to paint the house by himself? Now, before we jump in and actually tackle the specifics of the solution, let's take a look at what we think would be a reasonable answer. It would certainly make sense that it will take John longer than 2 hours to paint the house by himself, since it takes them 2 hours together to paint the house. It will also probably take him less than the 5 hours it takes for Lee to paint the house by himself. So we would expect an answer somewhere between 2 and 5 hours. It's always a good idea with any application problem to try to get a good estimate of what you think a reasonable answer would be. Now, what we're going to do next is to organize the information to what's known and unknown. And from the problem we can see that I've listed here that John and Lee can paint the house together in 2 hours. Lee can paint the house alone in 5 hours. And what we don't know is how long it takes for John to paint the house alone. Now, the couple other pieces of information, they're not stated specifically in the problem, but which we need to understand to work this kind of problem, is that any time that you have an entire job being done, we're going to represent that using the number 1. So in this case, painting the whole house will be represented using 1. And the second thing that we need to keep in mind is that the rate at which someone works is equal to the amount of work that they do divided by how long it takes them to do the job. In other words, the part of the job that they can do per unit of time. In this case, it would be how much of the house somebody can paint per hour. Now, if the units in the problem were given to us in minutes, then it would be how much of the job someone can do per minute. So let's next organize the information into a chart, define a variable, and set up the equation. Now, when we set up the table to organize the information, we're going to have 3 columns, time, work, and rate. And in the time column, it would be how long it takes to do the entire job. So from the problem, we're told that it takes Lee 5 hours to do the job alone, which would be painting the house by himself. And together we're told it takes them 2 hours to paint the entire house. So we enter the 5 and 2 in those blocks under time. And what we don't know is how long it takes John to paint the entire house alone. So we're going to let that be T. And you'll see that I've defined that using a sentence below the chart. Now, moving to the work column, remember that the entire job being done, or in this case the entire house being painted, would be represented by the number 1. So we put a 1 in each position there in the work column. And the rate, remember, is equal to the amount of work divided by time. So the rate at which John works then will be equal to 1 divided by T. The rate at which Lee works will be 1 divided by 5. And the rate of their working together then will be 1 divided by 2. Now let's be sure we understand exactly what these rates mean. So in Lee's case, for example, the 1/5 means that he can do 1/5 of the job, or paint 1/5 of the house in 1 hour. So again, rate represents the amount of the job that can be done per unit of time. Now it should seem reasonable that the rate at which John works alone added to the rate at which Lee works alone will be equal to the rate at which they work together. So that in fact becomes our equation. So we're going to write then 1 over T plus 1 over 5 is equal to 1 over 2. So next what we'll do is solve the equation. Now, to solve this equation, we of course want to eliminate the fractions. And so we can tell by inspection that the lowest common denominator of all fractions will be 10t. So what we'll do is multiply each term in the equation by 10t. And we can see that in the first term that the t's will cancel, and we're left then with 10. In the second term, 5 will divide into 10 twice, and we're left then with 2t. And on the right-hand side, 2 will divide into 10 5 times, and we're left then with 5t. And if we subtract 2t from each side, we end up with 10 being equal to 3t. And dividing each side by 3 will end up with t being equal to 10 divided by 3. Now in this case, we don't want to leave it in that form, but we want to change it to a mixed number, which will be 3 1/3. Now that does seem to fit with the estimate that we had at the beginning of the problem, where we said we thought it would take John somewhere between 2 and 5 hours to paint the house alone. So our answer is reasonable. And the final thing we'll do is to simply express this using a sentence. So we state then it will take John 3 1/3 hours to paint the house alone. Now maybe you've had the same thought I've had as we've done this problem. Either this house is very small or these guys are really, really good. So the final question is, would you hire these guys?